Hello everyone, I'm Feifan. Today I want to share about my final project, which is apply natural language processing to classify fake news. So specifically, I want to use a vectorizer tool in NLP to convert text into value that the model could understand and then use a classification algorithm to make judgment. The idea was actually inspired by the RNN and NLP modules that I learned from the course, like sentiment analysis and sarcasm detection. So at the time, I wondered if model could reading tones, will it be possible to tell whether news or true or false? I was also hoping to use this project to see which words appears most frequently in fake news and perhaps discover some interesting patterns. And next in this page, I will introduce you the so-called vectorizer. So when we process text, the computer doesn't directly understand the meaning. And so we have to convert text into a numerical form that it can be understood. And here I use counter vectorizer, which is the most common and basic vectorization method. Its principle is to count the number of times each word appears to form a word frequency matrix. So this approach, also known as a bag of word model, meaning that text is treated as a bag of words, regardless of the order of the words, only focus on how many times each word appears. In addition, we can also use n-grams to capture the sequence between words, where unigram is a single word, bigrams two consecutive words. For example, New York is a bigram. So this feature will help model to better capture the relation in between the context. So counter-vectorizer works best when data is clean, well edited, and among when the data set is very big. And because of its simple structure and fast speed, is particularly useful in many binary or real-time processing scenarios. So next come to the preprocessing part of the data. So at first we have real and fake two data files. So I combine them into a complete data set and scramble the order of the data so that the model will not be trained in the original order. Then we clean new values, which are basically missing text data, and remove the space between and after text. After that step, I put all the text in lowercase and make sure they are not treated as two different words. And then I remove the stop words that don't carry much meaning of it. Finally, I implement stemming process, which is unifying words like running, runs, ran into the word run, and reduce the type of word and make the model focus on the meaning rather than their forms. Next, we will apply three classifier models. They are logistic regression, multinomial naive Bayes, and passive aggressive. So the equation here is just give you guys a general understanding what they are. And here is a comparison table for the three classifiers. So multinomial NB is best suited for word frequency characteristics, such as text conversion with counter vectorizer. It is very fast on large-scale dataset. Logistic regression, although slightly slower than NB, is still very effective, and it is more stable when processing normalized text and features. And lastly, we have passive aggressive, which is a faster model, especially suitable for online learning or real-time streaming. So this page shows the confusion matrix and accuracy of logistic regression model. Confusion matrix is a tool used to evaluate effectiveness of model classification. So it compares the predicted value with the true value that divided into four regions. And I believe everyone is very familiar with this metric already that we learned in the class. So overall, the accuracy of logistic regression reached 99.45%. And following is the confusion matrix and accuracy for each model. And here, just take a very quick look at it. So after comparing the three, that we can find the passive aggressive model has the highest accuracy. And this page is showing the word most representative of real and fake news, judged by the model based on their weights. So on the left side is the most real, indicate that those words appears with the highest weight in real time, such as like Washington saying and Reuters. So they are neutral words often used in formal news source. The higher the score, the most the model tend to think it appears in real news. On the other side is the most fake, and those words appear in fake news with least weight or negative weight. For examples such as image features scary, hilarious, maybe become fake news is often come with lower or negative scores. So the stronger the model associated with, showing that the model has a strong association with fake news. And that's it. Thank you very much.